If you are constructing a building called a quantitative aptitude in your minds, I say number system is the base of the building. Like percentage, ratios, averages and speed maths are pillars, number system is the base of the building. So I say without building this base, there is no point in learning the other concepts as well. So in this series of videos, we shall learn in detail about every concept of number system. Hi, I'm Abhilash Varma. Welcome to Learn Online. In number system, we'll be learning totally 7 sub-concepts. They are classification of the numbers, like what all the different types of the numbers that are existing in number system, and divisibility rules, which are going to help you when you're doing the actual cancellations. And then we'll go by factorization, under which we'll be learning how to calculate the number of factors and different types of the factors. Well, the factorization will be again useful for us when we are dealing with HCF and LCM also. And then few high-level concepts like unit digit, factorials, under which we'll be learning trailing zeros, and finally we'll be doing remainder theorem and the most important one, HCF and LCM. Our very first concept is classification of numbers. Well, many students think that, do we really need to know the classification of numbers? I say yes, of course you have to. Because in few problems of number system, you'll be asked to calculate the integral values or natural number solutions or whole number solutions. But when you don't even know what they are, how can we actually calculate those integral solutions, right? So that is the reason why we need classification. Now, to start with, in the decimal number system, what we use every day, which has digits of 0 to 9. So in decimal number system, basically there are 2 types of numbers. They are real numbers and complex numbers. Well, you might have already heard about the complex numbers, which are in the form of x plus iy, where I is imaginary. Here we won't be discussing the complex numbers, rather we'll be concentrating only on the real numbers, because these are the ones which we'll be using in the calculations. Now, real numbers. Now, what are real numbers? The first thing I say, real numbers is nothing but a mother of all the numbers. Why? Every number we deal with, that always falls under real number. So what exactly the real number is? Any number that can be represented on a number line is nothing but a real number. So I hope you all remember this number line where on a line you have a 0 at the center and positive numbers on the other side, negative numbers on this side. So you can represent every possible number on the number line, be it a fraction or a decimal. So any number that can be represented on the number line is nothing but a real number. Now, these real numbers are further classified into 2 types. They are rational numbers and irrational numbers. Now, we'll get back to the rational numbers. Let us first understand. We'll get back to irrational numbers later. First, we'll understand what are rational numbers. Now, rational numbers are those numbers which are in the form of P by Q, where Q is not equal to 0. So, this is what many students think. Now, there is another condition, that is both P, Q are integers. So what are rational numbers? Rational numbers are those numbers which are in the form of P by Q, where Q is not equal to 0 and both P and Q must be integers. Now, why Q is not equal to 0? Any number divided by 0 is infinite or indeterminate. So which is not a number at all. So that's why Q cannot be equal to 0. Now, why P and Q must be integers? That you'll understand after a couple of minutes. I will get back to that point later, right? Now, rational numbers are further divided into 2 types. They are integers and decimals. Now, what are integers? Now, integers include all the positive numbers, negative numbers, and 0. Like, so we have all the negative numbers here, 0, and all the positive numbers. So these are integers. Now suppose if I eliminate this negative numbers from the integers. Now if we eliminate all the negative integers, what happens? We will be left with all the positive integers including 0. Now these are nothing but whole numbers. Now again, if I eliminate 0 as well from this, if I eliminate 0 from the whole numbers, what I'll be left with? I'll be left with only the positive integers. Now we call them natural numbers. So basically, natural numbers is a subset of whole numbers, which in turn is a subset of integers. Now, coming to the decimal numbers, let us discuss the types of the decimal numbers in detail. So under decimals, we have basically 3 different types of decimals. Now first I'll give you examples and let us look at the characteristics and then decide what kind of decimals are they. Now first set of examples goes like this, that is 0.5, 1.75, 4.86, 72.37, etc. Now second set will be something like this. We can have 0.3333. Again, we can have 0.16666. Again, 8.2424. Or let's take another example, 75.3535 ... So these are one type of decimals, and the final one 1.141, 3.1427869, 7.8285623 ... So these are 3 different types of decimals that we will come across when we are dealing with decimals. Now let us understand their characteristics. If you see here, every decimal is ending after 1 or 2 digits, or it can be 3 or 4 digits, but definitely they are ending 0.5, 0.75, 0.86, 0.37. So we call them terminating decimals. Again, if you see here, 0.333333 and 0.1666666 and 8.24242424, 75.353535 or 105.962962962962. So these decimals are never ending. So this 3 is going to continue indefinitely. 35 is going to continue indefinitely. We call them non-terminating decimals. And again, even if you see here 141, 142, 76, 89, 82, 85, 6, 2, 3. If you keep on writing, you keep on getting the digits indefinitely. Again, these are also non-terminating decimals. So now you must have understood that one characteristic of decimals, that is either it can be a terminating decimal or it can be a non-terminating decimal. Now another part. Now if you see, there is no much of repetition here, but if you see here, there is a repetition. 3 is repeating indefinitely. Here 6 is repeating indefinitely. 2, 4 is repeating indefinitely. 3, 5 is repeating indefinitely. So if you see a pattern of digits repeating indefinitely, we call it recurring. So we can say these decimals are recurring and non-terminating. Now can we see any recurring here? Well, if a decimal becomes a terminating decimal, there is no concept of recurring at all. So that's why this is non-recurring. So, non-recurring and terminating decimals, recurring and non-terminating decimals. Now here, well, you see a repetition of digits here. If you see, here there are no much repetition of digits, but in this case 8 repeated. But is there any pattern repeating there? No, there is no pattern being followed. So we call them non-recurring and non-terminating decimals. So in short, there are 3 types of decimals. That is, one is non-recurring and terminating, recurring and non-terminating, and non-recurring and non-terminating decimals. Well, now you understood all the 3 types of the decimals. Now, under rational numbers, we will be having 2 types of decimals. They are the very first one, that is non-recurring and terminating decimals, and the second one, recurring and non-terminating decimals. So these 2 decimals come under irrational numbers. Now if you speak about, under rational numbers. Now if you speak about irrational numbers, all non-recurring and non-terminating decimals are nothing but irrational numbers. So if you ask what is the definition of irrational numbers, we can simply say irrational numbers are non-recurring and non-terminating decimals. Now other examples include your value of pi and e. See, when you write the actual values of pi and e, they actually turn into non-recurring and non-terminating decimals. Apart from that, you can have root 2, root 3, root 5, or any prime number under root is always an irrational number. Why? When you bring this out of the root, you will get 1.141 something, which is a non-recurring and non-terminating decimals. So this is the very basic classification of the number system. Now apart from that, we have a slightly little more content regarding the natural numbers. So let us continue with that now. Natural numbers. Now natural numbers are all positive integers. We all know that now. Now these natural numbers are further divided into 3 types. They are prime numbers, composite numbers, and there is another type that I'll tell you after a couple of minutes. Now, prime numbers. What are prime numbers? The very common definition what we know is any number divisible by 1 and itself is a prime number. Now in that case, 1 should be a prime number because 1 is divisible by 1, 1 is divisible by itself, and it is not divisible by any other number. But still 1 is not a prime number. Why? Let us understand now. Well, the very first and the only even prime number is a 2. And we have 3, we have 5, we have 7, 11, 13, so on. Now composite numbers. The first composite number is 4. Apart from that, we have 6, we have 8, we have 9, we have 10, we have 12, and so on. Right? Now let us see what exactly these prime numbers are and what exactly these composite numbers are. Now if I write the factors of 1, I'll get 1 and 2. 3, 1 and 3. 5, 1 and 5. 7, 1 and 7. 11, 1 and 11. 13, 1 and 13. So what is happening? Any number which has exactly 2 factors is nothing but a prime number. Now coming to the composite numbers, if I write the factors of 4, I'll get 1, 2, 4. 3 factors are there. 6, 1, 2, 3, 6. Again, if I write for 12 directly, I'll get 1, 2, 3, 4, 6, 12. 6 factors are there. Now if you see, every composite number has more than 2 factors. And every prime number has exactly 2 factors. Now if you see, the third type of a number, natural number, is 1. Why? What are the factors of 1? There is only one factor for 1, which is 1 itself. So that is the reason we always say 1 is neither prime nor composite number. Now can we define what are prime numbers? Any natural number which has exactly 2 factors is nothing but a prime number. Composite number, any natural number which is having more than 2 factors is nothing but composite number. And 1 is neither prime nor composite because it has only 1 factor. Now, in this process of classification, we forgot one thing. About the rational numbers, I told you number must be in the form of P by Q and Q is not equal to 0 and both P comma Q must be integers. Well, we didn't discuss about this part why P and Q are integers. Let us check this out. Suppose if I tell number 3 by 2, is it a rational number? Yes, because it is in the form of P by Q. Q is not equal to 0. Both P and Q, 3 comma 2 are integers. Suppose if I write 2 by 3. Yes, of course. What if I write 7 by 8? Yes. What if I write just 5? Is it a rational number? Yes, because 5 can be written as 5 by 1. So, P by Q, Q not equal to 0, both 5 and 1 are integers. Now, if I write root 2 by 3, is it a rational number? No. Why? If you observe, this root 2 is not an integer because that root 2 is an irrational number. So irrational when divided with another rational number, that will always be an irrational number. That is the reason why I told you both P and Q must be integers. One last thing we need to learn in natural numbers is coprime numbers. Now, what are coprime numbers? Let me give you a few examples. Based on that, I'll explain you what exactly these are. Suppose if I take 2, 3, they are coprime numbers. If I take 5, 7, they are coprime numbers. If I take 4, 9, they are coprime numbers. If I take, let's say, 14, 15, they are also coprime numbers. Now, can you observe anything? Well, you might be thinking, coprime numbers are 2 prime numbers. Here it is right, here it is right. But here, neither of them are prime numbers. Here also, neither of them are prime numbers. So, what are coprime numbers? Let us understand. Now, if I take 2, let me write the factors of 2. I'll get 1, 2. For 3, I'll get 1, 3. Likewise, for 5, I'll get 1, 5. For 7 as well, 1, 7. Now, for 4, if I write factors, I'll get 1, 2, 4. For 9, 1, 3, 9. Again, if I write for 14, 1, 2, 7, 14. For 15, 1, 3, 5, 15. Now can you see anything common here? If you see 2 and 3, there is only one common factor between them, that is 1. Now here as well, only 1 is the common factor. For 4 and 9, still 1 is the common factor. For 14 and 15 also, there is only one common factor, that is 1. So now you must have understood what are coprime numbers. Coprime numbers are any 2 numbers are coprime with each other if they have only one common factor between them, that is 1 itself. It means they should not have any other common factors between them except 1. Now 2 prime numbers are always coprime numbers. Well, there is another definition for coprime numbers which is nothing but HCF of 2 numbers, let's say x comma y is equals to 1, then both x and y are coprime with each other. Now, if you have highest common factor as only 1, highest common factor itself is 1 means there won't be any other common factors between them. So that's why HCF of coprimes is always 1. Now, apart from that, what else we can understand here is, as you can see here, 2 prime numbers are always coprime with each other. Apart from that, you take any 2 consecutive numbers, they are always coprime with each other. Like 14, 15, 9, 10. If I take 27, 28, you take any 2 consecutive numbers, they are always coprime with each other. Now, what is the use of coprime numbers? Well, that you will understand when we are dealing with HCF and LCM. To watch more free videos, download our LOL application from Play Stores. If you are benefited by these videos, please like and share our videos, and also do not forget to subscribe to our YouTube channel so that you don't miss any of our new videos that we upload regularly. If you have any queries or suggestions, please drop them in the comment section below. Also, if you want to reach out to me or any of my team members, you can always do that through any of the social media platforms, and the links of which are already provided in the description below.